Hey, hello everyone. Welcome back. This is the continuation video to the last video, which we discussed SDE, stochastic differential equation, and Brownian motion. Due to power issues, my video got interrupted. So I'm, trying to explain the same concept from where we left. So let's get started. So in before video that we discussed how to calculate the average. I already explained that Z1 represents the direction that each step takes. Let me re-explain the concept again. So drunk person, either he can take right direction or he can take left direction, which represents each step Z1 plus 1 if he takes a right direction, Z2 which he takes to left direction. Now we have to find out the average of these steps. I mean, in general, they may take in random walk, they may take many steps, but for numerical, for this example purpose, I'm just taking the 2 steps only. So there is a probability of taking these 2 steps is 0.5, which is half of probability. So plus 1 into 0.5 plus minus 1 into 0.5, which is 0.5 minus 0.5, which is become 0. So average of these steps become always 0. Average of these steps always 0. Now we found the average. Our next step is to figure it out variance. Variance is a measures like how much a random variable like Z1 in this case spread out from its average or mean. It tells us like how scattered the possible values are. If you want to figure it out the variance, then we have to use the formula variance of Z1 equal to expected value of Z1 square minus expected value of whole square. This is the formula that we use to calculate the variance. Now I'll explain step by step how we calculate the variance. So I'm continuing with the earlier example only. In Z1 that we took plus 1, Z2 we took, this is the right direction and this is the left direction, right? There's a probability of taking this right direction is a 0.5 and probability of 0.5, which is 50%. And now if I want to find my first, this part, which is a mean square, right? Mean of Zi, which is plus 1 into 0.5 plus minus 1 into 0.5, which is 0.5 minus 0.5 equal to 0. So now we figured it out, one of the component in the variance, which is the mean. Now second step is like we have to calculate expected value of square values, which is this one, expected value of square values, which means 0.5 into 1 square plus 0.5 into minus 1 square. This is a plus 1 square, this is a minus 1 square. So here we get 0.5 plus here also 0.5, because minus 1 square 1, 0.5 becomes a 1. So our expected value for squared values is 1. The expected value of Z I square is a 1. Now just insert these two values 0 and 1 in this formula, variance Zi equal to 1 minus 0, which is 1. So what this one is all saying about, this means the spread of Z1 values plus 1 or minus 1 around the mean let me explain with graphically. So suppose this is a 0 and this is a y-axis and this is a x-axis, and here 1, 2, 3, 4. Let's imagine. So what this variance is saying that how much spread. If you say in the graph, then what is the spread? It is a 1, right? Gap between this 0 to 1, 1, and 1, 1. So variance is speaking about this one. What is the spread? Basically, it gives us the spread, but the thing is like this one is in unit square. That we have to remember. This means of the spread of z1 value +1 and -1, right? And it's around the mean 0. And this one is sorry, 1 is unit square. So now we got variance and we got mean, and to find out standard deviation, we just take the square root of variance. In this case, our square root of variance is above. We already found variance is a 1. So here standard deviation is also 1. What it means? Let me again explain in the graphical. 1. So variance is 1, right? So every one movement, and there is a chance either it goes standard deviation, deviate from the mean, either 1, either +1 or -1. This is plus or minus 1, plus or minus 1. So imagine, let's take few paths. Drunk person that took few paths like +1, +1, -1, -1, and +1. Let me represent the same thing in a graphical way. So our variance is a 1, right? So first step, and we know our deviation is also 1. From starting point or here, it is a 0, right? So first step, this is a 1, 2, 3, -1, -2, imagine. So first step, he took the right. So one step, we reached one step, and also and in second step also again he took one more step. So again one more step. Here we reached, and now he took -1 step, which means again he come back to here, and again he took fourth step, again the fourth one he took -1, and finally in the fifth step he again moved back to +1. So end of after 5 steps, and he landed here from this position to this position. So the Brownian motion generally it helps that this randomly movement, it helps us to model the random movements and its position. So we started to model this using the discrete way. Even if you say this is each individual step is a discrete way, then we are going to cover how this can be converted as a continuous way and calculate the Brownian motion using the continuous. But before that, I want to give one more example. I think this is enough for this one. Yeah. Now let's say step 2. So to get Brownian motion in a continuous way, what we have to do? we have to take the some interval time, and that interval need to divide it into n steps, which means suppose if I take the time interval 0 to 1 example, which one is a capital T, let's, or I can also write like T. Okay. Now, what I'm trying to say here, we have to divide this time interval by n number of steps, which is, suppose in this case, capital T divided by n. So it captures the changes in T, which is delta T. Let's imagine delta T. This is so. In example, if I want to numerical example, if I want to convert, or if I want to say it in, then what I'm trying to do here, 0, it is a 1. And what I'm trying to do, I'm dividing by the n. So in this case, my T is here 1 divided by what I'm trying to do, I'm dividing by number of steps. First, I'll explain with the simple example. In this case, I'm just taking the 4. So 1 by 4 is 0.25, which means from 0 to 1, I'm just dividing my graph into 0.25, 0.25, 0.25. This is 0.25. But in graphical way, I say that I can say that 0.25, 0.5, 0.75, and finally 1. We already discussed this is the variance, right? But however, this variance is in a squared way. But if we want to find out the standard deviation, variance we already know, which is 0.25 in this case. After we divided this n steps time interval by n steps, which is a 4 we took as an example, and our variance become 0.25. This is the squared one. And if we want to get the proper deviation, then we have to take 0.25, square root of 0.25, so plus or minus 0.5. So now we have variance, standard deviation, and zi. Let's take in this steps, we took the 4 steps, right? So 4 steps, let's imagine that drunken person again took 4 steps. The first step is a +1, and second step is imagine -1, and third step is +1, and again +1. So these are the right direction, and we took the second step as a left direction, and right direction, right direction. Now, the probability of taking each step is a 0.5, right? So now we have to, if we want to figure it out, what is the where he located after 4 steps. So for that, if we want to calculate that, then we have to use our zi into standard deviation. In this case, zi into square root of plus or minus square root of delta t. So in the first step, step 1, what he did, he took the right direction, which is a +1, right? +1 into our standard deviation. What is the standard deviation? 0.5, right? So the 0.5. And in second step, he took the left direction. So -1 into 0.5. Step 3. Again, he took right step, which is a +1 into 0.5. Step 4. And he took right direction, which is +1 into 0.5. Now let's see, this is a 0.5, this is -0.5, this 0.5, this 0.5. Now we got all these steps with the values. Now if we want to know the total or his position, where he is in after 4 steps, total position after 4 steps, that W 4 1 equal to 0.5 minus 0.5 plus 0.5 plus 0.5. These two cancel out. And so after 4 steps, then he reaches to 0.1. And we already discussed that variance of each step is 0.25. And if we want to know the total variance, like how many steps that he took, total variance, each step of variance into number of steps he took. So individual step variance, we already know 0.25, and he took totally 4 steps. So 4 into 0.25 becomes 1. So that is what it is. So after 4 steps of each 2.5, 2.5, 2.5, and it becomes a 1. So let me explain the same this concept with a graphical way now. So this is the y and x, and we want to see this position. And we divided, this is a 0 and this is a 1, and we divided into the 4 steps, right? So each step 0.25, and after 0.5, 0.75, and finally 1. And we know the variance of each step is 0.25 difference, 0.25 difference. Now let's see whether the same, whatever the value that we got it, is it a correct way in graphical or not? I mean, I just translate this mathematical steps into graphical way. So we know the deviation is 0.05. What it means? He took 4 steps. What are those 4 steps? First, right direction, left direction, and again 2 right directions. So imagine, so first step after 0.25, he took the right direction, right? So right direction means plus, and our deviation is a 0.5. Imagine this is the 1 and this is the 2, and we should not move from 0 to 0.5. We should not take the deviation as a 1, because we already calculate our deviation, that is shows a 0.25. So it means like by moving each variance or each step, then he can either go plus 0.5 or minus 0.5. It's not like plus 1 or minus 1. So in this case, after moving the first step, which is our first step is the right direction, which is a positive. So 0.5 he moved. Let me change my color. 0.5 he moved. So the first point is here. And after that, again, he took left direction, which is a negative. So for positive, I'm going up, and negative, I'm going down, 1 step down, which is 0.5 step he's moving down, negative. So third step, which is again he took 0.1, right direction, right? So third step again he took from here to right direction, which is 0.5. He's there here in 0.5. And again, after final step, he took the right, which is again 0.5. So 0.5 to 0.5, which is 1. So if you see, our graphical representation also saying the same thing, how this 1 comes. This he is at 0 after taking the 4 steps, and he reached to the 0.1. Reached to 0.1. So now we understand how to calculate the Brownian motion, right? But it is not yet completed yet. Why? Because till now whatever the examples that I gave and graphical examples also we have seen, these are all a discrete one. But Brownian motion is not a discrete one; it is a continuous. Even if you remember earlier, uh, 4 features that we discussed, and one of the feature is that continuous. So how to convert these discrete steps into the continuous? So for that, what we have to do, we have to do these steps, whatever the steps that we took it in this example, right? For example purpose, I just took the 4, but in real time or for continuous purpose, we have to, n reaches to infinity. So when we divided t or interval by large number, then our delta t approaches 0. Okay, so what it is, meaning that the discrete random walk that becomes a continuous path. The sum of all these minor or tiny steps become a Brownian motion. So let me write it on my screen. So what is happening here? Let n becomes infinity, and delta t becomes a 0, and this is we are, by taking these steps, we are transforming the discrete random walk becomes a continuous path. By doing these two steps, it discrete random walk becomes continuous path. So by central limit theorem, what it says, the sum of all many tiny random steps looks like a normal distribution. So we can say that t or w of t follows normal distribution, which is 0 comma, we know the variance is t. This is the average of the steps, and t is the variance of steps. Yeah. Now we understand how a discrete random walk turns into a continuous Brownian motion. So I'll explain